Okay, so remember from an earlier lesson, we learned how to negate the conditional statement, right? This is called the conditional statement. So to take the negation of conditional is P and not Q. Okay, so now let's negate this. So this says for every x in D, comma, if P then Q. So to take the negation of this, we take the negation of the universal for every, and we get there exists. And then anytime you have to put there this, you have to say such that. And I'm just going slowly through this. You don't have to take this many steps. Then I'm going to take the negation of the if P then Q. And you know the negation of the if P then Q is P and not Q. So this is the negation of that statement. I just took a couple steps just to help break it down for discussion more than anything. Okay, so I want you to negate this. Ooh, I have two things. For every x in the reals, comma, there exists a y in the reals such that xy equals 0. Okay, let's take it in steps, just so you can see how I'm breaking it down. So to take the negation of this is going to make it from a universal to an existential. There exists an x in the reals such that, anytime you have there exists, you have to have such that, and then I just slowed down and I said, okay, now I'm going to take the negation of the second part. So to take the negation of the second part, and I guess I just wrote the thing down again. So this carries along, right? Okay, take the negation of this. To the negation of a there exists is a for every y in real. Anytime you have for every, comma, then you take the negation of this, xy does not equal 0. So this is the answer. Again, you don't have to break it down into so many steps. I'm just trying to help break it down. So there exists an x in the reals such that for every y in the reals, xy equal 1. So breaking it down, so to take the negation, so take the negation of a there exists is a for every, so you might put the comma, and then I'm going to negate the second part. So to negate the for every y in reals is that there exists in real, and every time you have a there exists, you say such that, and then I take the negation of the statement. So this is the negation. Okay, so this is, these are written formally, and I want you to be able to write it in words, because you got to be able to figure out what it's saying, right? So for all x that are real, comma, right? There is a y in the reals such that xy equals 0, right? Okay, so is that true? Okay, stop and think. For all x's, there is a y. So start with the x's. Is there a y so that x times y will equal 0? Yes. I can always let y equal 0, right? Give me any x value. I can find the y value to make x times y equal 0. Yes, you always use y equals 0, and it'll always work. Okay, so this is saying there is an x in the reals, right? So that, or such that, it doesn't matter, it doesn't have to be specific. For every y in the reals, x times y, x times y doesn't equal 0. Okay, so for every x, there is an x that works for every y. There is an x that works for every y so that x times y doesn't equal 0. No, if x equals 0, there's no y that works, right? So if for every y, there's an x, there's no real, I'm sorry, I said it wrong. There is an x that works for every y. So if I have oh, sorry, I said that wrong. So if y equals 0, there is no x that works, right? I'm trying to find an x that works for every y so that x times y doesn't equal 0. Well, if I have y equals 0, there's no x that's going to make the x times y equal 0. So no, not true. All right, let's figure these last two out. So there is an x in the reals. I guess I'm supposed to say that informally. In the reals, right? In the reals, so that for every y in the reals, x times y equal 1. Okay, so let's see. So there is an x that works for every y in the reals. There is an x that works for every y in the reals so that x times y equals 0. No. There's no one x value that works for all y's, right? That's what it's saying. There is an x that works for every y. There, just like this one, there is an x that works for every y. Doesn't work that way. Okay, hopefully that's clear. So this is saying for every x in the reals, for every x in the reals, there is a y in the reals so that x times y doesn't equal 1. So for every x, there is a y. So pick an x. So for every x there is, you can find a y value so that it doesn't equal 1. Yeah, just don't pick true. You can always find a y that is not the multiplicative inverse, right? That's what the multiplicative inverse is to make it multiply to equal 1. I can find one. Give me an x, I can find another y that will make it not equal to 1.